go. So let's open a new file. This is number 15. Write a program that approximates the value of pi by summing the terms of this series. 4 over 1 minus 4 over 3 plus 4 over 5 minus 4 over 7 plus 4 over 9 minus 4 over 11. Let's see. Actually, we use the terminal. We could use here's the shell. Let's just do it. Let's do 4-1 minus 4-3 plus 4-5 minus 4-7 plus 4/9 actually, 4/11 plus 4/13 minus 4/15 plus 4/17 minus 4/19. It's close. It's close. I think it gets much closer the more you do, right? So, but that's what it's saying. It's saying that, yeah. So let's. It's supposed to be pi, right? It's supposed to get real close to pi. So let's do this. And I think it's all about patterns. So that's the first thing we're going to do is we're going to take. Let's just take that, copy it here. And let's call this pi1.pi. And this is going to be basic formula for pi. And we'll say this program calculates an approximation of pi based upon user input of how many terms to sum, based on how many terms to sum. So let's do pi1.pi. Okay. So the definition of approx pi, and that's going to be, yeah. So we're defining approx pi, our function. We'll call it later. And let's figure out what we're going to do. Okay, so let's put it in here. So let's call this numbers to sum. So numbers to sum equals int input. Please enter the number terms you wish our program to include. I guess we're going to sum them, right? Because we're adding a positive, then we're adding a negative, but it still can be considered a sum, right? Because it still can be considered addition. Adding a positive, adding a negative, because it could be plus and then minus and then plus and then minus, or it can be plus a positive and then plus a negative and plus a positive, which can be considered a sum. So for a program to sum, that will garner an approximation of pi. So that's essentially what we're doing. So all right, so let's do that. So then we're going to call this num sum. So when we call approx, invoke the function here, merge to sum. This is our argument here, which is like the automobile, and then the parameters here are like the parking space. So the argument is going to be num sum. So okay, so so the pattern is going to be, so we're going to start with 4/1. So it's going to be so we're going to call it num equals, so num is always going to be 4, right? So let's call that, let's make this capitalized, because a lot of times, like, capitalize stuff, it becomes it's considered a constant. In certain languages, like it locks them in as constants. I don't think that it works that way in Python. But yeah, so let's do num equals 4. And then so the numerator is 4. So the denominator, so our denominator is going to change. So that won't be a constant. That's going to be, yeah, let's make the numerator always positive. Then makes the denominator, it starts with 1, right? Denominator is going to be 1, and then 3. It's going to be 1, and then -3, and then +5, and then -7, and then +9. Because remember, we can put the negative anywhere in the fraction. We can put it in the numerator or the denominator, or we can put a parenthesis. But I think it's easier if we make the numerator always +4, because it's just easier for us to make, and then just for us to change that one. There are a couple ways to do it, obviously, but I think this is the way that I feel that is the most comfortable for me right now with what I know and how my brain works and whatnot. So okay, so let's do for n in num sum range, because the int is not iterable. But the range is iterable. We can iterate in the range. So for n in range num sum, do this. Okay, so we've declared our variables outside of the loop, so they won't get messed up. So now we're gonna do num divide by denom. So let's call that sum, right? So sum. So let's call this sum equals 0, right? And we'll declare that outside of the loop. Sum equals num over denominator. So 4/1 plus. So let's do this like we did before. So sum equals sum plus num over den, right? Now we're not going to need any parentheses because this is already going to do this first. Sort of the PEMDAS, which is how Python works. That takes precedence. The division takes precedence. And then we're going to update denom as in denom, the den, den, actually variable, equals den times -1. So does that make sense? Like 4/1, right, is going to be num, so 4/1, right? And then once it goes through the loop. So then it's going to be sum equals 0 plus 4 over 1, right? So 0 plus 4 over 1. And that's our new sum, right? Then it goes through here and it says, okay, now den is going to be den times -1. Nope, it's not going to be times -1. It's going to be there's a couple ways to do it. One of the ways we can add 2. I think that's what we should do. So den equals den So let's see. So I think it's going to be the absolute value of den, but we don't want to update that. Let's see if we do this in one shot. So it's going to be 1. So how do we go from 1 to -3 to +5 to -7? Is it going to be times -1? No, it's going to be den times, because times -1 would be -1, 1, -1, 1. So we can do, you know what? Let's do den times -1, right, which makes it negative. So 4 over 1, then it's going to be 4 over -1, so then that makes it negative. Then we want to add 2 to den, so then we do that after. So den equals den plus 2, right? Or we can do it all in one shot. So there are a couple ways to do it. You can do den equals den times -1, and then add 2 to that. So are we going to add 2 though? So if we did 1 becomes -1, add 2 becomes well, -1 becomes -1. Yeah, that's messed up. We need to do this first. So we're going to do the absolute value of den. So the absolute value of den, yeah, that's what we're going to do. This is just to make it much easier. So we're going to do den equals the absolute value, right, plus 2. Because we're always going to go up from 1 to 3 to 5 to 7 to 9. So we have to keep that in place. So the absolute value of den, right, by itself, right? So, and then we're going to add 2 after. To make sure that these are together. So we take the absolute value of den. So right now this is 1. Okay, fine. Absolute value of 1 is just 1. Fine. Plus 2. Now the den equals 3. Now go down here. Oh, nope, it's now -3. So that makes this negative. Right? Then go through the loop again. And now we're trying to get to +4 over 5. So now we're updating this, the sum. And then den equals the absolute value of den plus 2 again. Right? So we're going to do absolute value of den, which is now it's not -3 anymore, because you made that negative. We're going to make this denominator now positive. So we're going to take the absolute value of den, which is 3. It's always positive, right? Because it goes 1, 3, 5, 7, 9. So we want the absolute value of den. We add 2. That adds us 2. And then we just alternate the signs, which is going to be den equals den times -1. That's all we're doing. A couple ways to do it. I think the last time, I think this showed up in another problem I worked on. Maybe it was for launch code, or I don't remember exactly, but it's probably a common problem for early, computer science students. So, but I think I did it differently. Yeah, I think I had the negative in the numerator, but seeing all these 4s just makes it so much easier. And then also I just wanted to maybe try something a little different. The 4s, makes me want to make num just a constant. The numerator 4. So anyways, so then that should be that. And then we got to return something, obviously, right? So then we're going to return the sum, and that should be good. I think that should be good. So let's try it. Let's try this out. Okay, I messed up here. I gotta print this. It returned it, but it didn't print it. So I gotta print that. Let's go here. Let's do 20. Oh, I messed this up. Yeah, I messed that up big time. Big time. Okay, so sum equals sum plus num slash den. Right? We've already tried it. It's 4 over 1. So absolute value of den plus 2. So it's going to be 1 plus 2 is 3. Now, den equals den times negative 1. So it's negative 3. So now 4 over negative 3. That should be right. So for n in range, so den equals... No. I think den is 1. I think we started out as like... It's going to start out with 0 equals 0 plus 4 over 1. And the numerator just keeps staying the same. It should be good. Let's see if I made this right. Numbers to sum goes in here. Prox pi. Okay, so somewhere I did this wrong. So let's go here. Let's just... Oh, maybe it's the number 0. So for n in range 0, no, I don't think it's an issue because it should do it 19 times and it should come out with the sum. All right, I got an idea. So we're gonna test this by printing the sum each time and see what happens. See where we get messed up. So let's just say 3. Oh, so it starts out at 4? It keeps going lower. Big drop. I don't think it should do that. Okay. So then the other thing I think about is, okay, well, it shouldn't be a problem, but, let me just fix that. Over den. And you know what? This probably needs a parenthesis. I bet you that's the issue. So the absolute value of den plus 2. So that's going to be way out there. We have to make sure that this is just this. And then den equals den times negative 1. That shouldn't be a problem. Okay, so let's try it again. So we're going to enter 4 times. Oh, it's going way down. Way down. Yeah, this is definitely... I made a mistake here. So we're going to resolve this. Yeah, going to negatives. It shouldn't go to negatives. Okay, so it's probably the pluses and the minuses. So it's always going to be plus. Sum equals sum plus, negative 4/3. Right? Plus 4/5. Plus negative 4/7. Thinking that we did this right. Absolute value of den. So let's do this. We're going to print den each time. That's crucial, right? And then we're going to print num each time. Or, yeah, num. So every time I go through the loop, we're going to make sure, we're going to know here exactly, like, where the mistake is. Like, what am I not seeing? So 4, negative 3. Oh, there it is. It's not updating to negative. Interesting. It's 4, negative 3, 4, negative 5, 4, negative 7, 4, negative 9. That's the problem. The 4s are fine. 3, 5, 7, and 9 is fine, but we're not alternating the negative. Oh, I know why. Because I called, yes. This is the problem here. Because I called it the absolute value, I'm not remembering if den is positive or not. So that's not good. So what I want to do is, I actually want to change this big time. This is actually something where I want to change the numerator, because it's going to be much easier, I think, if we just change the numerator only. So we're going to do sum equals sum plus num over den, right? And then the numerator is the one that we change. So the numerator equals the numerator times -1. And then the denominator equals, or not equals, num times -1 is assigned to the variable num, right? And is updated and assigned. That equal is assignment, it's not equal sign. So yeah, it's assigned. So okay, so this is going to be even easier, right? So because we're just alternating the numerator, so after 4/1, that's the first time it does it. Then we update the num variable to -1, to num times -1, so it just alternates. And then den equals, that's going to be 1, 3, 5, 7. Yeah, so den is just going to be den plus 2. Right, so then let's try that again. Much easier. I was trying to make it a different way, but, oh, not defined because I changed the capital. So let's go back down here. Make sure we do that right. All right, let's do 3 times. Yes. So, because remember, it doesn't print 4/1 because we updated it before we pressed the print. If we pressed it up here, then it would do 4/1. But 4/1 is going to be our first value that we're looking for. And then it's going to be -4/3, +4/5, -4/7. Okay, cool. Now we're getting close. All right, so now we did it right. Now let's delete these. I think we're good. Let's save it. It saves it on our atom. Let's do 20. Yes. Let's run it again. Let's run it again. Let's do a bunch. There it is. 10,000 times. Look how beautiful it is. And then it also said that you could subtract, if you wanted to subtract, your program subtract the approximation from the value of math pi. You see how accurate it is. So let's do that. That'll be our last step for this. So print the accuracy is the difference between this and math.pi is, and this is going to be what we return here, right? This minus math.pi. Let's check that out. That's going to be a parenthesis and parenthesis because it is a function, the print function. I think that'd be cool. And then make sure we import math. I think we're good. Let's try it. Let's do 10,000. Oh. -9. No, that's wrong. That's wrong. We're going to subtract them. But I subtracted them. Let me open this big. Okay. Is minus math.pi. So it should be the sum is going to be, make sure, yep, that's going to be a float. Math.pi is going to be a float. How come that was a, so we're just going to subtract them, right? That shouldn't be a problem. It's going to be this number minus this number, which should be a tiny result, but we will solve it. We will solve. Okay, let's see. Let's do 1,000. There it is. Nice. Oh, no, let's go the other way. Let's go the other way. Not going to be negative, right? It's going to be positive, right? Let's do math minus pi. So let's delete that. Minus pi. Minus. And we'll make sure that that is done beforehand. So 1, 2, 3, 4. 1, 2, 3, 4. Yeah, because you want to evaluate this first. So sometimes I do this in math class too. I think sometimes I over parenthesize stuff just to make sure of like keep it like evaluate this ASAP, you know. So this might be one extra parenthesis than we need, but I want to make sure we don't make this mistake. So okay, so let's do this. No, it shouldn't be that. Yeah, I think it's it should be positive. Oh, but this ends up being bigger. Is 9? Doesn't make sense. Is 10? This doesn't even make sense. The difference. I think this ended up working better. Let's do this. Let's do approximate pi, numbers to sum, minus math.pi. And let's just call this the absolute value. Let's see if this works. All right, so 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And then it'll evaluate this first. But yeah, because it's going to be the absolute value of the whole thing. I think if I did this, it would take the absolute value of this. But because I'm doing this, this parenthesis is going to be connected to the one over here that takes the absolute value of this whole thing. I think that's going to be our solution. All right, let's do it. No, we keep getting 9, which is close to 10. That's crazy. All right, now I'm going to try something tricky. So what if I add these up? Let's see if I just added these up. It's just nuts. It's just nuts. We keep getting like 10. All right, so let's do 1,006. Yeah, there it is. So how come the plus is fine? And they can't even subtract. It's unbelievable. There's got to be an issue with the Python. There's probably a reason, obviously a reason why this is in this book. Or there might be a special issue with the Python. So maybe, I don't know, maybe if we rounded it, let's try this. Let's try a couple of ideas. Let's change it to approximately. Let's have a little fun because I think I'm gonna go down the right path here. So now let's round. Let's round this. Two spaces. So I have an idea. Let's round math.py. This is the other idea I got. Okay, so let's round this. Math.py, comma. Actually, that should be, let's do 10. Right? And then let's round this one. Round the return value of this function by 10. Now let's subtract those. Let's put this in parenthesis. Actually, this should be fine. All right, I think we should be okay. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. I think we should be okay. I know this should be outside of that because that's going to be the only argument because that ends up going in here when we run this function. So that needs to be outside of that parenthesis. But then this is going to be connected to that because the round function itself is going to be applying to this. It's going to say round this return value here, or round this value, which ends up being return value of a function, 10 spaces. And then we're going to subtract math.py rounded 10 spaces. And let's change it to 20, or let's do 12. I think 12 is good. It's 20. Okay. Hopefully this works. This is the first thing I'm thinking of. I mean, it's might not be right, but all right. Yes. I don't know why it worked. You can't get like 9.999. I'll ask. Maybe I'll find out. I'll talk to an expert in this field, and they're probably going to get annoyed just because these are such simple questions. But and also just I think the research component is helpful. I think just jumping online and doing a lot of this stuff, yourself and just sort of sniffing around. But if someone doesn't mind if someone doesn't have an answer, like if someone has an answer at the ready, you can ask them. If it takes them like 30 seconds. I mean, So yeah. So I'll see if somebody wants to answer this question. But it's a funny thing. I think that the issue with rounding, so it was a rounding issue. Like since we rounded them, it was fine. But without rounding them, you saw it. It was like negative, 9.99, which is just a strange number. So, but anyways, hopefully this was good. This is kind of a fun one, and that's the thing I'm learning as well. With all of this is it's there's always going to be a lot of questions that you want to go answer, and sometimes you have the time for it, sometimes you don't. Sometimes you jump onto Google and you get it quickly. Sometimes you're going to go down like a rabbit hole and it takes a long time, and so you want to keep your time management in flow. And like, how crucial is this to figure out? Like, can I just use the round functions from the math, the import from the math library, to make it easier until I have an opportunity to bring this up to maybe an expert or in a certain venue, So these are all issues that will come up, and I'm just getting really comfortable with not knowing a lot of stuff. I mean, that's the thing about learning something that's so beautiful and amazing, yet just massive. I mean, it's unbelievably massive. Like how how much there is to learn and how it's completely dynamic. It's ever changing, in terms of these languages and popular languages and what applications are out there, in terms of jobs. And so, but yeah, just I think being comfortable with this process is helpful, and knowing that you might not have every single question that you have answered by the time you go out the next day, I'm getting more and more comfortable with, because I'm still trying to fail forward and like keep learning and keep plugging away and keep, turning in assignments. So, all right, guys, thanks a lot.